Here we are with chapter 8. Nice to be talking to you today. You are either watching this during the spring break, great for you, you are getting ahead, or you're watching this after the spring break, great for you, you took a break and now you're recharged. So, either way, it's good. So, let's go ahead and press on. So, what are we doing on this chapter? This chapter is when we're going to start using the balance equations that you know how to do now. Those balance equations, when you balance those equations and you get the coefficients for each chemical compound, what you are doing is creating conversion factors. So now we're going to be able to convert from given reactant to products, from products to reactants, and so on. And we're going to be able to predict how much we should be able to get once we take all this into the lab. So to understand that, here are the concepts that we need to study. We're going to look at a balance equation, and we're going to recognize the numerical relationship, which is nothing more than the conversion factor or the mole to mole ratio. And we will see what that is. So the mole to mole ratio, which is going to be a conversion factor, we're going to use it to do calculation between products and reactants. So if we can do it with moles, we can do it with mass also, because all you have to do is take the mass, find the molar mass of the atom or the element or the molecule from the periodic table, and convert it to moles, and then you can go back to number 2. And then we are going to learn some new concepts: limit and reactant, theoretical yield, and percent yield, which are really easy to explain using cooking. If you buy a box of cookies or the mixture for to make cookies, and the box tells you that you should be able to make 10 cookies, but when you make the cookies on the oven, something goes wrong with the oven and you only make 5 good cookies, so you only get to do 50% of them. So that's the percent yield. The percentage of what you actually made compared to what you were supposed to do, to what you were supposed to be able to do. So that's what we're gonna call the percent yield. The theoretical yield is what the box of cookie mix told you. According to the box, in theory, you should have been able to make 10 cookies. And the limit and reactant is if you had to make the cookies with eggs and flour, and you're supposed to use 2 eggs for a box of flour, and when you go to the fridge, there's only 1 egg, that's going to limit you. You're not going to be able to get the 10 cookies. You're only going to be able to get, in theory, half of them, because the egg is limiting you. So the same theory applied to chemicals. And we're going to be doing that with moles, and we're also going to be doing it with mass. And once we do that, we're going to see also that reactions can generate energy, exothermic, or can absorb energy, endothermic, and we can relate that energy that is produced to the balance equation, therefore coming up with a new conversion factor. Instead of mole to mole, we're going to see mole to energy or energy to mole. So that's what we are covering in this chapter. So let's begin with this first one. Recognize the relationship between chemical quantities in a balance equation. And we're going to start with this problem. Given this balance equation, write conversion factor that you will use to convert from moles of chlorine. So given the moles of chlorine, can you find the moles of NaCl? And we're going to use the train track, and like before, you're going to cancel what you don't want, and you're going to put in here what you want. And the question is, where are we going to get these numbers from? Well, we're going to go to the balance equation, and the moles of NaCl are going to be 2. The moles of chlorine are going to be 1. So we just built a conversion factor. And this conversion factor is moles 2 moles. So you saw how I was able to create a conversion factor just by looking at the balance equation. So that's how we relate numerical quantities to a balance equation, by just looking at the coefficients and using them to our convenience. What other conversion factors can I get from this reaction? Well, I can say that for every 2 moles of sodium, I need 1 mole of chlorine gas. I can also say that for every 2 moles of sodium, I can produce 2 moles of sodium chloride. I can also say that for every 1 mole of chlorine, I can produce 2 moles of sodium chloride. So all I did was I related the moles of Na to the moles of chlorine to the moles of sodium chloride. So I use every single coefficient by pairs on the equation, and that's how I get to relate quantities given a balanced equation. So once you have a balanced equation, you can find conversion factors just by using the coefficients and using them as moles or molecules. And that's your daily work. So with this daily work, do A, B, and C, which are going to allow you to reinforce what I just talked about. So moving to a new learning objective. After leaving this one behind, the new learning objective is, can you carry out mole to mole conversions? What are the moles to mole conversions? What we just did, the mole to mole conversions. And we're gonna use those on the train track by canceling what we don't want and finding what we want. So carry out mole to mole conversion between reactants and the products in a balanced equations. It has to be balanced before you can do anything like that. So let's do a problem like this. For each reaction, calculate how many moles of the product. So the product for this one is going to be ACl, for this one is going to be water, for this one is Na2O2, and for this one is sulfur trioxide. So given 1.75 mole of the reactant in color, in this case hydrogen gas, can you find how many moles of the product you can make? Once more, we don't want the moles of H2, so we put it there, and we want the moles of ACl, and we put it here, and we go to the balance equation. For every 2 moles of ACl, I have 1 mole of H2. Therefore, if I have 1.75 moles of hydrogen gas and everything else is more than enough for it to react 100%, I'm going to get 3.50 moles of hydrochloric acid just by looking at the conversion factor. Let's do the next one. So the next one is going to be given 1.75 mole of the one in color, O2, can you find how many moles of the product you can make? Once more, use the train track, cancel what you don't want by putting it at the bottom. On top, you put what you are looking for, just like you have been doing through all the previous 7 chapters, and then find the coefficient from the balance equation. This one, oxygen is going to be 1, and water is going to be 2. So the same as before, we're going to have 3.50 moles of water created. What about the next one? So for the next one, once more, given 1.75 moles of the one in color of sodium, can you find how many moles of the product you can make? On this case is Na2O2, train track. We don't want the moles of Na because we're looking for the moles of Na2O2. These numbers come from the from the balance equation. So Na2O2 is 1 and the sodium is 2, which tell me that we're gonna have 0.875. Is that what I get? 1.75 divided by 2, 16, 15, 7, yep, 0.875. And the last one. On the last one, once more, given 1.75 moles of the one in color, sulfur, can you find the moles of the product, which is going to be sulfur trioxide? We cancel the one we don't want. We put on top the one we want. And then we find the numbers on the balance equation. Moles of sulfur trioxide is going to be 2. Moles of sulfur is going to be 2. So this is going to be 1.75 moles of sulfur trioxide. Because the sulfur is 2 to 2 to the sulfur trioxide, which is 1 to 1. So that's how we do the mole to mole ratio to do a calculation, by using the coefficients we find on the balance equation and by setting up the train track the way you learn how to do it. And if you have another way of doing it, by all means, feel free to use that, as long as you are understanding what you're doing. And here's your daily work. You're gonna be doing the same for A, but you're gonna find how much of this and how much of that for each of the products. And then you're also gonna do it with oxygen, and you're gonna do it for both products also. So you should have 4 answers on this problem. And when after you do that, then you do these problems, which is more of a typical problem on chemistry. So now that you understand how it's done, then you're gonna start seeing this type of problem that is more or less what you wanna see on any modern textbook. And once you do that, we can say that we understand how to do the mole to mole conversion using a balance equation. And that's all I have for right now. So make sure that you understand mole to mole and how to use it, because next time we meet, we're gonna go from mass to mass, which you already know how to go from mass to moles or mole to mass. So it should be a breeze for you. So see you soon.